Okay, so I am going to show you some examples of the different operations that we have with radicals to help you guys out. So the first thing that you'll remember we learned how to do last week was to simplify radicals. And we do that by finding the prime factors. And the reason we do that is because we are looking for anything that multiplies into it more than once, because a square root or a radical with an index of 2, remember we don't write it if it's a 2 just because it's the most common. A square root is looking for things that multiply together twice. So it doesn't have to necessarily be a prime number, but we get it down to the prime factors so we can see the very bare bones kind of what's multiplying into it. So I know that the prime factors of 9 are 3 and 3. So I'm going to replace that with 3 and 3. And those two appear twice, so that means I can take the square root of that. If I take the square root of a number that multiplies together twice, it's just one of those numbers. So that's just equal to 3. There's nothing left inside of the radical, so I don't need the radical anymore. It's just empty, and so it goes away. So then I'm going to repeat that with 48. I'll find my prime factors. Okay, and I'm looking for things that appear more than once. So I see that I have 2 2's right here and 2 2's right here. It has to appear exactly twice for a square root. So I can take the root of those 2, and I'm left with a 3 inside that only appears once. So if I take 2 2's outside and I multiply them together, and I have a 3 left inside, I end up with 4 radical 3. And again, we are not changing this actual number. If you enter radical 48 into the calculator, you'll get the same thing as you would if you calculated 4 radical 3. We're just simplifying the expression so it's a little easier to understand. And I can repeat again with 52. Sometimes I circle ahead of time the prime numbers that I see that appear more than once. That way I'm just planning ahead what I'm going to do. Should end up with 2 radical 13. And 108, I'll show you the birthday cake method. You can do that as well. But you have to plan ahead on space. I might run out of space here. Almost out of space. So assuming I did that right, I got 2 times 2 times 3 times 3 times 3 is equal to 108. So I see that I have 2 3's right here and 2 2's right there, and there's one lonely 3 right here. So that's going to stay inside. So I take a 2 out, a 3 out, because I took the square root. You can think of this as when a number appears more than once, it makes a perfect square. So 3 times 3 is 9, and I can take the square root of 9, and that's 3, and it would end up by itself outside. So that's all I'm doing. And I have that 3 left inside, so you should end up with 6 radical 3. Alright, then we can use simplification to help us add, subtract, multiply, and divide radicals. I can use it to help me add because, like we learned in class, the radicand, the number inside, has to be the same in order for us to add them together. It's just like variables. If I had 3x plus 3y, the variables are different, so I can't add them together. But if I have 3x plus 3x, I can get 6x because the variable is the same. We're talking about the same thing. So if I'm talking about 3 times the radical 3 and 4 times the radical 3, I end up with 7 times radical 3 because the radicand is the same. Right here, it is not but you can simplify them to make sure they are the same, or to see if they are the same, and then if they are the same, you can add them together. So 2 radical 5 I can tell is already simplified because 5 is a prime number. So I'm going to simplify 20 and see what I get. And I have 2 2's right there. So I know I'm going to take the square root of those and put it out front. And I multiplied 13 times 2. If you take a number out, you multiply it by what's already there. So I got 26 radical 5. So right here I have 2 radical 5 plus 26 radical 5. So I end up with 28 radical 5. Okay, and I can do the same thing down here. Right now they're not the same at all, so I'm going to check and see if I can make them the same. So 12, and I'll do 32 over here. So 12 is 2 times 2 times 3. And 32 is 2 times 2 times 2 times 2 times 2. And I take out numbers that appear twice because those make perfect squares. And over here again, taking out numbers that appear twice and leaving in the numbers that only appear once. So 14 radical 3 plus 5 times 2 is 10 times 2 is 20 radical 2. And right here, the radicands are different and they're as simplified as I can make them, which means that this cannot be added together. So this right here is the simplified form. It's done. Let's go ahead and now look at subtraction. Subtraction is the same idea as addition, so I'm just going to do one example. I'm going to make sure I need to have the radicands the same, the number inside the radical symbol. And if they are not the same, then I will not be able to add them together. So I'm going to simplify 44. And if I check 11, I know that's a prime number already, so I cannot simplify it anymore, so it's just going to stay as is. So I've got 2 2's here. I can take 1 out front. And I end up with 3 radical 11 minus 8 radical 11. Which is equal to negative 5 radical 11. And I could subtract again because the radicand was the same. On multiplication, like we talked about in class as well, if even if the radicals are, or the radicands are different, you can still multiply. We're going to multiply the radicands together. And if there's a coefficient, you're going to multiply them together. If there's no coefficient, you just imagine it's a 1. So I'm going to multiply the coefficients. 3 times 3 is, or 3 times 1 is 3. And I'm going to do 30 times 6, which should be 180. And I'm almost done. The last thing I need to do before moving on is to simplify 180. So I'm going to check over here for my prime factors. So I have 2 times 2 times 5 times 3 times 3. Oops. 3 times 2 times 3, because I took the 2 and the 3 out. 5 left inside. 3 times 2 is 6, times 3 is 18, radical 5. So the most simplified form of this, although it is the same number as 3 radical 180, is 18 radical 5. And I'm going to do the same thing right here. There's no coefficient here, so again, imagine it's a 1. 2 times 1 is 2. 27 times 5 is 135. And I'm going to simplify that 135. Okay, so I got 5 times 3 times 3 times 3. And I can pull out the number that appears twice. And 5 times 3 stays inside, so it becomes 15. And I end up with 6 radical 15. And now for division. There are a couple different kinds of problems you're going to see with division. So I'm going to show you all of them. So one of them right here. Some of you noticed in class. So what we've talked about is that you need to get the radical out of the bottom, or out of the denominator of the fraction. You cannot have that there, and that's just the rule in mathematics. We don't like that there. And it makes it easier for us to have a standard form if everybody does the same thing and getting rid of that and moving it to the top. So one way to do that is to multiply by radical 2 over radical 2, or something that we call that is rationalizing the denominator. And just like I do up here with multiplication, I'm going to multiply the radicands. So 18 times 2 is 36. And 2 times 2 is 4. And I know that the square root of 36 is 6 because it's a perfect square. And I know that the square root of 4 is 2 because it's also a perfect square. And 6 divided by 2 is 3. But there is a shorter way of doing one like this. So if I have a radical on top and bottom, I can look at those numbers and see if they can be divided. So this is only if there's a radical on top and bottom. So for example, I can think 18 divided by 2 I know is 9. So if I turn this into a radical 9, because I divided 18 by 2, I know 9 is a perfect square, and that's equal to 3, which is the same answer we got over here. But we only did 2 steps as opposed to all the steps over here. So that's one way you can check and see if these are divisible. So right here in the number below it, you can see again that 6 is divisible by 3. Even though there's a 5 in front, you can still do this. And 6 divided by 3 is 2, so I would end up with 5 radical 2. I can also do it the other way again, so I can rationalize the denominator and get rid of the radical 3 on the bottom. But it's just a lot more steps. And then if I simplify 18 really quickly, I end up with So I did all of these steps right here, but I still got 5 radical 2. So that is one option. However, sometimes you're going to run into a problem like one of these, where either you only have a radical on the bottom, so there's nothing to divide, or 6 is not evenly divisible by 5, so that's not going to be an easy one to do. So in this case, this is where you have to do the steps of rationalizing. So you multiply by whatever radical is on the bottom over itself. And again, we talked about this in class, but that's because radical 2 over radical 2 is just equal to 1. We are not changing this number. We just want to cancel out the radical on the bottom. So I end up with 3 radical 2 over, we don't multiply the number in front here. We're not trying to get rid of that, just the radical on the bottom. So that stays the same. And we multiply the radicands inside. Radical 4 on bottom now. And this is 3 radical 2 on top still. And I have 2 right here. And I know the square root of 4 is 2. So the reason we multiply the radical by itself is because that puts the same number inside of this radical 2 times. If I find the prime factors of 4, it's 2 times 2, which is a perfect square. So what happens is I make a perfect square and it cancels out and I end up with 2. So then I have 3 radical 2 on top in the numerator and 2 times 2 is 4 in the denominator. And this is still, if I calculate what 3 over 2 times radical 2 is, it's still exactly the same as 3 times radical 2 over 4, but this is the accepted standard form in math that you're going to see. So the same thing here. I only need to worry about the radical on the bottom, so I'm going to multiply by radical 5 over radical 5. And that's because this is going to cancel out because I'm putting the same prime number inside of that radical twice. So I end up with 5 radical 30 over radical 25. 5 radical 30 over the square root of 25 is 5. We have the same thing on top and bottom here, so it cancels out. And I'm left with radical 30. And if you can simplify that number, you should. But if I check the prime factors of 30, it is 5, 6, and 2, and 3. And none of those things appear more than once, so I know that it's already as simplified as it's going to get. Okay, if you have more questions, email me. I would be happy to send you more examples.